Everybody, welcome to the 10 o'clock or the 11 o'clock session for the Global Summer 2020 Azure Data Fest. I know I got that probably confused. I just want to introduce Mr. Robert Walters. He's going to talk about building highly scalable IoT streaming solutions using Azure Event Hubs and MongoDB. I'll start the recording, and without further ado, I'll hand it off to Robert.
All right, thank you.
Sure.
Hi, I'm Robert Walters, product manager for connectors and things at MongoDB. And today I'm going to talk about how to use the MongoDB connector for Apache Kafka to move data between Azure Event Hubs and MongoDB. So as some of you might be aware, there's the Kafka Connect feature, which is in preview in Azure Event Hubs. And this is a great way to sort of bridge the data between Event Hubs and Mongo and actually many of the other connectors that are available for Apache Kafka. So today we're going to cover a lot of different technology. So Azure IoT Hub, Event Hubs, and MongoDB. And I realize that not every single person who is watching is comfortable with all the technologies. So we'll take a few minutes to give ourselves a primer, mostly around MongoDB. I mean, I assume you probably know IoT Hub and Event Hubs. But this will be followed by a deeper dive on the MongoDB connector for Apache Kafka. This connector is used with Azure Event Hubs by way of the Kafka Connect service, which I just mentioned, which is in preview. And after that, we will look at how MongoDB can be used within the Microsoft IoT Reference Architecture. And at the end of this session, we'll talk about what really makes the MongoDB document model so good for IoT and time series data. So you're joining the IoT track in this conference, so I assume you know what IoT is, but if you're visiting, I'll just level set with a definition. IoT really is a single term to describe these many situations where big data is captured, analyzed, and acted upon. So these data originate from sensors and devices that have potential to generate massive volume, velocity, and variety of data. So there are many industries that leverage IoT, as you know, and each one of these has different required capabilities. So if we consider an IoT device in an emergency room, for example, that has a persistent and reliable network connection. But if we look at something like a drilling application on an oil rig that uses a satellite link to get to the internet, I mean, those are very different, requirements and things that are there. So there really is no like one best practice or one architecture that will fit everyone's needs. Today, we're going to review a couple of those options that you can use, but it's by no means like this is the prescriptive you must use in MongoDB this way or Azure Event Hubs this way. It's just sort of some suggestions to build upon and to give you some ideas of the art of the possible. So we're going to talk about IoT and Microsoft Azure offers a lot of the end-to-end solutions from sensor to cloud, as you're learning about today. Two of the components of the Microsoft offering we'll focus on the discussion with MongoDB is Azure IoT Hub. And as you learned, it's a high-scale service enabling bi-directional communication of devices through WebSockets and MQTT and native HTTP over TLS. There's also Event Hubs, and Event Hubs is a high-scale ingestion-only service for collecting telemetry data from sources, but these sources are not necessarily devices. They could be from other systems like weather feeds or social streams. So Event Hubs can be considered more of a generic messaging platform like Apache Kafka. And I believe, but I'm not 100% sure, but I think that Azure IoT Event Hubs or Azure IoT Hubs uses Event Hubs under the covers and sort of making IoT Hub like a superset of Event Hubs, offering the IoT specific features like the per device identity and command and control capabilities that you'll find with that platform. So we'll explore both of these. Specifically, we'll be diving into to the Event Hubs. So here's just a sneak peek of what we'll cover a bit later, but basically we're discussing two of the more popular ways to bring MongoDB data into the IoT suite. The first way is by way of IoT Hub to Event Hubs, and the next is IoT Hub via Azure Functions. But first, for those of you who may not be familiar with MongoDB, it's a company founded in 2007, IPO'd in 2017. We've had explosive growth over 2,000 employees worldwide, and we're the most popular document-oriented database in the world. So if you haven't looked at us in a while, a lot has changed. We even support transactions. So that was a big thing a couple years ago, is there's no transactions, but now we are ACID compliant, among many other features and capabilities. So why is MongoDB and this document model so great for IoT? Usually IoT projects start with a pilot, only focusing on some basic attributes of physical objects. And if we map these attributes of a thing, we could enumerate it into a nice singular list that fits well into a table. And, as your needs grow, you might add new sensors or devices, and these might require the need to define different properties and schemas and actions. And applying these new requirements to a relational database model, you can imagine how complicated things can become relatively quickly. So now if we add the variability of user-defined data, and any change to your relational schema requires really a massive amount of work with more unit testing and lots of added risk, and ultimately slows down the development of new features in your product. So that's where JSON and the document object model come in. So MongoDB has this flexible document model. It's based on JSON, and it's simple to define and group together attributes and events from your things. So here we see a direct comparison between a relational database schema and a JSON representation of the same data. While the data needs to be spread into multiple tables in a relational database, all that data for a particular asset is represented in one JSON document. Expensive joins are not needed, and the data for different types of devices can look different without additional needs in terms of data modeling. And if you think in terms of physical storage of this data, in relational tables could be spread across different areas of the disk, causing multiple disk IOs to occur from a simple query, versus with MongoDB and a document object model, all that information is in one document. So effectively, one disk IO, you have all the information needed to satisfy that particular query. But JSON is not just optimized for storage of static data. So as your needs change and as you add more sensors with different attributes, you start to add security policies and information about the actions of assets. These data could easily be added without changes to your application. So being able to adapt to changes quickly gets even more important as soon as we start talking about handling large data volumes. So we've talked about the power and flexibility of JSON, and there's a clear advantage towards using JSON. And there are JSON-based standards like JSON LD to represent linked data. These standards, it's what's also used in the Web of Things standard by the World Wide Web Consortium to describe digital representations. So since MongoDB is based on JSON, it's a straightforward to adapt such specifications to your existing applications. And JSON LD it's an ideal way to represent data and metadata, as it provides context to the stored data. It provides a global unique identifier for an object and still allows developers to use easy naming conventions while keeping a high level of precision. So on a side note, JSON LD, it's the representation behind Google Knowledge Graph. So now let's take a look at a real life use case of just time series data in MongoDB, just to give you, an example of a customer that has used MongoDB for IoT in this context. Mercedes-Benz is a global car company, and a high level, all their modern cars transmit status every few minutes into the vehicle data conditioning service. This data is used and available to other lines of business, such as call centers, retail, as well as by customers themselves via mobile application. In addition, historical analysis is performed to track the quality of cars and its components. And if we dig down to the details of the schema used by Mercedes-Benz, we see an example of the usual complexity when we talk about IoT and specifically digital twins. And digital twins are a digital representation of a physical object. So it's another sort of popular IoT term and use case. And it's not just a few sensors sending data, but in this case, and in common with IoT scenarios, we have compound objects with lots of details about vehicle data. If we look at the vehicle ident data subdocument and the current basic data subdocument, which includes basic time series data like mileage and batteries and tanks. And then we can look at more detailed information about the electronic control unit containing details about hardware and software and diagnostic trouble codes. You know, all in all, it's a lot of fine granular data stored together and efficiently. And so with Mercedes-Benz, you know, we're not talking about just a couple megabytes, it's multiple terabytes of data for this application. But it's not really the limit of MongoDB. And another example, we have a global leading IoT platform that leverages MongoDB for the backend, and they have a wind park monitoring platform where they have about 25 terabytes of hot data produced by 6,000 wind turbines. So, you know, it's across lots of different industries. And of course, internally at MongoDB, we drink our own wine. We have about 25 billion data points in MongoDB Atlas, which I'll talk about Atlas a little bit later. And thousands of customers have found success through MongoDB and IoT. And so here's just a list of some of them. So you can see across many different industries, they've found great success with MongoDB and IoT. So now that we've covered kind of what MongoDB is, just for those of you who might not be familiar with it, and why the document model is such a great fit for IoT, there's one more point of clarification before we dive into, you know, the Kafka connector and how everything works with the Microsoft IoT suite. I'm going to talk about MongoDB and MongoDB Atlas somewhat interchangeably, but it's important to note that MongoDB and Atlas are the same engine code at the end of the day. So whether you choose to self-host MongoDB, meaning that you spin up an Azure VM, you install MongoDB and you configure it, you patch it, maintain it, or you choose Atlas, which is a turnkey solution where you can spin up a MongoDB cluster on Azure and you could hook a VNet to it, to your local application, and you receive a connection string and sort of have MongoDB manage that for you. That decision, you know, obviously is up to you. Atlas does provide some of these other capabilities I'm going to talk about, like online archive and some of the things that you might want to leverage in an IoT solution, but they're both one and the same as far as a features and functionality standpoint. Today, we're going to be working through a demo, and this demo is going to be a very simple demo that will showcase how to move data to and from an event hub using Kafka Connect and the MongoDB connector for Apache Kafka. So there's going to be a Python application that will create fictitious stock symbol data, and it will insert it into a MongoDB collection called source in a MongoDB Atlas cluster. There's the MongoDB connector for Apache Kafka will be configured to that source. It'll read the data pushed into that collection, and it will insert it into the Azure Event Hub. And this connector will also be defined as a sink, where it will pull data from the Azure Event Hub and insert it into Atlas in the sink collection, where the Python tool will just read from that sink collection. So as data is showing up in that sink collection, it is just displayed on the screen. So we're doing a simple round trip of data from Atlas through the connector to hubs and back to Atlas, just to kind of show you, first of all, the configuration of the connector and to sort of experience about how data flows through the connector so you can go through. In this example, the full write-up of this demo that I'm running through is available on our blog site. And there's a GitHub link, which I'll show you at the end, which has all of the code for the setup and the Docker container and all that sort of thing. So the first thing we'll do is I'm going to give you a brief tour of Atlas, because Atlas will be the MongoDB cluster that we'll use. We'll set up some of the security behind it, so you're aware of that piece, and then we'll get into defining the Azure Event Hub itself. So I'm going to jump over here. So what you see on my screen here, this is the MongoDB Atlas page. And I have two clusters running for a moment. So I've already created the cluster that we will use for this demo. But you can see if you wanted to sort of follow along, or in the future you wanted to play around with it and spin it up. When you hit the new create cluster button, you have the option to create a global cluster. So you can pretty much specify anywhere in the world for doing global performance. So if you wanted to spread your rights globally, if you wanted folks in India or in Japan, for example, to have really good read access, you can combine different secondary reads pretty much all over the place. As you can see, we do support all three cloud providers. So today we're going to talk about Azure, and you can see we have a number of Azure data centers that we do support. I'm going to choose Eastern US. And as I scroll down, you'll notice that here is the number of different size tiers that we offer. We do not charge by RUs, so there's no like RU calculation or anything like that. It's just this is the cluster that you get. Each one of the nodes in a MongoDB cluster will contain what you see here. So for example, if I chose this M30 tier, I'd have a 3-node replica set with each node having 8 gigs of RAM and 32 gigs of storage and so forth. And you can see we can scale up quite large to a quarter terabyte of RAM and disks and so forth. And so these IOPS are the guaranteed IOPS, and there's under the additional info you could see the number of max connections and stuff. So we definitely scale as your needs increase. We have an auto scale feature that can automatically scale the cluster as needed. Some of the other important features to note are that you can select which version of MongoDB, and you'll notice that 4.4 is in beta. That's going to be released relatively soon, so you'll also have that as an option to go to as well. So you're always going to get the latest version of MongoDB. You also can enable cloud backups, and so what this is going to allow you to do is back up the data with down to a level of 1 minute recovery point objective. So by default it's 6 hours, but you can tune that down to as little as 1 minute. You can also shard your clusters with a click of a button. So you can, if you want to horizontally scale out and dramatically increase your performance, you can do that from here as well, and enable the BI connector, which I'm going to talk about later on when we start talking about visualizing data. And that's pretty much it. You give it a cluster name and away you go. So that does take about 5 to 7 minutes. So in that case, I kind of created my Atlas cluster beforehand so we can kind of continue on with things. Once your cluster is created, there are 2 things you should know. The first is there are no users created by default, and access is denied to everybody on the internet and pretty much anywhere. It's just there is no access. So what you need to do is you need to create a user to access this, and I had created this AEH user beforehand. I'm using the Scram password method, but you can use certificate-based authentication, and then in AWS, you can use AWS's IAM authentication as well. You can specify very granular permissions, so I can do some built-in roles here, or I can specify specific permissions to use. And since I'm a fan of the least privileges, I created this user with only read-write access to just that database Event Hub demo. So that's as part of a best practice to do. I created that, and this person is this user identity is created. The other very important piece is network access. So I said by default there is no access at all. One of the things you can do is if you have a web application or something where you don't know which IP they're coming in on, maybe it's like a mobile application that's directly connecting to a database, which is not necessarily the best practice, but you can specify 0000, which basically opens up to allow incoming connections from anywhere on the internet. But the best practice is to add an IP address. So if you wanted to add your specific IP address or your application address, you can do that from here. Because I am demoing this, I just added it, but I also added a time where this will expire after 6 hours. And so you can do that too, where if you're just temporarily spinning something up and you want to test it, you can do it from there. You can also set up a peering connection. So if I hit add peer connection, I can choose Azure, and now I can specify my VNet settings. So if I had an application that's running in an Azure VM or some other piece of Azure, I can hook it up from here and specify just the resource group name and the VNet name and subscription ID and set it up from there. So that's just what I wanted to cover as far as an overview of Atlas. I'm going to jump back here to these slides and continue. Great. So as we mentioned previously, if you're using Azure IoT Hub, there are 2 main ways to interact with MongoDB. The first way is through Azure Functions, and here you'd create an Azure, you create a function app and a function, and use either the C# driver or Python, or simply insert the data into MongoDB using any one of the many languages that we support. We support all the ones that you can use with the Azure Functions. So, and then the second method we are going to do, and that's the one we're really going to focus on today, is using Azure Event Hubs. So Event Hubs offers you a lot of flexibility since you can easily integrate other data sources to the hub. So you can also leverage other pieces of the Azure platform with Event Hub data. And it's the best way to get data into MongoDB now is through this preview capability called Kafka Connect. So right now, I'm going to go through and define my Azure Event Hub and the namespace. So I'm going to jump back over here, and we're going to, there we go. So I'm going to open up a command shell window, and rather than type lots of things out, I'm going to come in here and just paste in some commands. I'm going to use the Azure CLI to do this. So here I'm going to create a new resource group called IoT group. I'm going to create a new Azure Event Hub called Mongo IoT Hub. And once this is created, we need the connection string to the Event Hub itself. And in this demo, we're going to use the root managed shared access key. This is not really a best practice in production. You probably want to create another access key and strip down the permissions, so maybe it only has write access or read access or whatever your requirements need. But for purposes of a demo, we can do this. So in this namespace creation here does take about 20 or 30 seconds. So it'll come back. I just tested it before. And once we have this access key, what we want to do is copy the actual connection. There's going to be a string called endpoint, which will provide the whole the shared key access password, as well as the URL to the IoT hub, in this case, the Mongo IoT hub on there. Once we're done with that, we're going to create there it is, now it's done. So I can come in here and I'm going to view the password. And what we want to do is copy this endpoint right here. So this is our connection string to our Event Hub. And so I'm going to paste that here so I have it with me, because I'm going to paste in a number of different things. So now that we have that, we have the connection, I'm going to create a topic called My Topic, or an Event Hub called My Topic. And all I'm doing here is I want to test that everything's set up correctly. I'm testing that my user credentials are working, that my network is configured correctly, and so forth. And the tool I'm going to use to do that is Kafka Cat. And for those that are not familiar, Kafka Cat is an open source utility, and this is Confluence documentation on it, but there's a GitHub link that you can see from here. And it just makes it really easy to connect to a Kafka topic and read data and push data to it. So something to consider looking at if you're using Apache Kafka or the Azure Event Hubs through, in this particular way. So I have created this topic right here. And the other thing, this is specific to Kafka Cat, if you're interested in using it, is that there is a file, a configuration file, that you can pass to it, so you don't have to keep passing lots of command line parameters. And the reason why you would want to do that is because in order to connect to Azure Event Hubs, you need to specify these 4 parameters. So every time you would launch Kafka Connect, and I would imagine any other tool, you have to specify the SASL mechanism, the username, the password, the security protocol, all of this stuff. And in Kafka Cat, you can just give a configuration file, put this information in there, and then all you're doing is just passing the configuration file. So here, I'm going to copy that endpoint that I copied before in here, and I'm going to save my configuration. So now I can come in here and I'm going to run Kafka Cat. I'm going to pass that configuration file, and I'm using the option -C. And what that means is I'm going to use this as a consumer. So here I'm just listening to that topic I created. So I'm going to go over to another shell window, and I'm going to issue the same command, but I'm going to use a -P, which is a producer. So in Kafka speak, a producer is when you're writing to a topic, and in a consumer, obviously, is when you're reading it. So I can say, hello, Azure Event Hubs. And so this tool, just whatever you type in, it sends through. You can flip it over here. You'll notice it already popped up on my consumer. So I know that this round trip is happening. I know my connection string is working, and I'm ready to go. So I'm going to close that down and flip back over to my slides. So before we get into configuring this, I want to talk a little bit about what is Kafka Connect. So Kafka Connect is part of Apache Kafka, and the support for this feature is available in preview in Azure Event Hubs. And essentially, you can use Kafka connectors with the Azure Event Hubs through this Kafka Connect service. And MongoDB is not the only connector. There's a plethora of other connectors out there, such as like MySQL and Postgres and many others that you can use for both a source and a sink. So the whole purpose of Connect, and it really makes it so developers don't have to build these sort of one-off bridges to Kafka, and it avoids them having to rewrite applications and spend time figuring out how to interconnect these various systems. Because if you think about Apache Kafka, it's really used in a lot of data-driven applications. It's used as ETL. So a lot of these main use cases of doing things like change data capture and things like that, it works well when you could take a data source and just easily integrate it. And that's really the purpose of Kafka Connect. So if we look at the MongoDB connector for Apache Kafka, we support both source and sink. And when we configure it as a source, we're taking data from MongoDB and pushing it into a Kafka topic, or in this case, an Azure Event Hub itself. And behind the scenes, what's happening is in MongoDB, we enable change streams on the database and collection you're sourcing from. So change streams creates events, much like change data capture does in SQL Server and other platforms. And from these change stream events, we could filter it so we don't capture every single event. So you can listen to maybe inserts, or maybe insert only when a certain field like temperature gets above a certain point. Or maybe you want to capture only updates or deletes, but no other operation. So it gives you that flexibility to determine what kind of data will go into your Azure Event Hub. And when we configure the connector as a sink, we're talking about taking data from a Kafka topic or an Azure Event Hub and inserting it into a MongoDB collection. So in the sink, you can do some basic post-processing, like filtering out fields that are pushed into MongoDB, etc. So once we stand up the connector, you can configure it to be a source or a sink for multiple collections or any combination. Your single connect deployment effectively can be configured to support multiple sources and sinks. So you don't need to keep spinning up a new Docker container for every single time you want to do a sink or a source. You can define them all within the same one. It's got some flexibility there. So now at this point in the demo, I'm going to build out the Kafka Connect piece. And so here's where we have some more options. So we need to host Kafka Connect service itself. And so you could spin up an Azure VM. You can install Kafka Connect itself and manage that. You could also put this in a Docker container and run through Azure containers if you wanted to. I'm going to run this Docker container locally since this is just a demo. So that's what we're going to kind of go through here. So I'm going to jump over here, and I'm going to jump back over to this guy. So what we have here is I have my VS Code open, and what you're seeing is a Docker Compose file. So for those of you familiar with Docker, a Docker Compose file allows you to throw multiple services, define multiple images to build out and create like a network, and so all the services can talk to each other. You can define what ports to open. You can define environment variables to run inside those containers. So when it comes to Kafka Connect, and when it comes to really demoing anything, for example, that uses lots of infrastructure, this is really a great way to quickly spin up different kinds of infrastructure. Much like the configuration file of Kafka Connect, Docker also has one. And so since I don't want to keep changing my Docker Compose file, there's a .env file which will define the environment variables of my Bootstrap server, which is my Event Hub configuration, as well as my SASL configuration. So here, what I want to do is paste in my connection, my endpoint connection that I had before. So I'm going to do that right here, and then save this. There. So I just updated it such that when I do my Docker Compose up, it will actually connect to the correct Azure Event Hub. So I did Docker Compose up, and what's happening now is that I'm downloading the Kafka Connect from Confluent, the image. I am also building the MongoDB connector, the latest one. So right now you'll see there's a build command in here. I'm reaching out to this Docker file, Mongo Connect, and that is actually going to pull the latest version and build the latest connector and install it in my Confluent, in my Kafka Connect service itself. So that's what this does here. You'll notice as we scroll down, I'm opening port 8083, which is the one we use for Kafka Connect, and I'm defining all of my environment variables. And so this is pretty important because this is how Kafka Connect knows where to connect to, where's the Apache Kafka topic, or in this case, where's the Azure Event Hub, and what kind of security parameters and things that should use to call that. So it's pretty straightforward. You can also define networks here. So if I had multiple containers going, I can actually add, like MySQL Server or, Mongo or whatever in here and like link them all up together in sort of one big happy infrastructure. So that is, that's Docker. And so right now what I'm going to do is we're going to start configuring our source connector. And so to save time on typing, I have typed this all out. I'm going to jump back over to my command line here. I'm going to paste it in here and we can walk through this. So the way that Kafka Connect works is you can send REST APIs. You can configure it through REST APIs. And so here I'm going to, that's why I'm using curl. I'm going to post an HTTP post, and I'm going to specify a JSON document that is my configuration. So here I'm calling this a Mongo source stock data. I am going to provide a key and value converter. So the thing with Apache Kafka and Connect is that you can send data with JSON, with Avro. Essentially to Kafka, it's just binary. It doesn't really know what kind of data it is, and so you can convert it so the topic is aware and can receive the same kinds of data. So we're using the JSON converter. The other option that is interesting is publish full document only. When you receive a change stream event, since this is a source, we are receiving change stream events. We are receiving the metadata of change stream and the actual full document itself. So the metadata of change stream might say things like, this is the underscore ID of the actual change stream event. This is coming from database foo and collection, bar. All of that you might not want to flow through your whole application. You might not care, or you might care. Doesn't really, either way. But if you say publish full document true, we're just getting the piece of data that is your user data. And so that's what I want to do here. I just want my stock ticker symbol and the value. Of course, there's a connection URI that you can paste in here. You can. You notice I do have my username and password exposed. If you did not want to expose it, Kafka Connect has a way to privately push connection URL information, so you can just reference that within it, so you don't have to call it out here on the configuration. And at last, you can specify a topic prefix. So this is something that is prepended to the name of the topic that's going to be created. So I'm looking at the database Event Hub demo, and my collection is source. So my topic is going to be demo.eventhub demo.source. So that's going to be it in its entirety. So if I hit enter, it is going to come back and it's going to give me this as my sort of result, and it's saying that my source is now configured correctly. And on the back end, you can see that it is creating a bunch of events back there. So this is sort of like reading the log file of what's really going on in the back end. Now I'm ready to define my sink. So I define my source. So now I'm listening to my events that are MongoDB Atlas in the source collection. And I'm going to paste in here, and this is going to define the sink. So this is going to say from this topic, demo.eventhubdemo.source, connect to my Atlas cluster. And in the database Event Hub demo, the collection sink is where the target should be, where I'm going to write. And of course, here you can see that the JSON converter is going to take whatever's on the topic, or in this case, the Event Hub, and convert it to JSON. You also can, the sink supports schemas. So if you're using JSON schemas, you can enable them, or Avro, or JSON, or plain text. So once I do this, I hit enter, and now my sink is configured. So right now I have that pathway fully defined, and I have a Python application which is available on the GitHub repository. And as I mentioned before, this Python application will create this fictitious data and send it to that to the source collection here. So I'm just going to paste in my Atlas connection string, and I'm going to run it. And what it's doing is it's sending the data out. And as it reads the data off of the sink, meaning that the data actually made the round trip, it's displaying it. So the data you're seeing here is actually made it all the way from the Atlas cluster through Azure Event Hubs and then back to the Atlas cluster again, where I'm reading it from a different collection. So obviously, Not incredibly practical example. However, it is showing you the configuration of the connector and how to configure it in the round trip of data. So this is just sort of giving you that experience to see what all the basic components are made of and how to configure them. So I'm going to stop this for a moment here and jump back over to my demo slides. Great. So let's start talking about the MongoDB and the Azure IoT reference architectures. So Microsoft has published an IoT reference architecture that talks about warm and cold data layers. And here is a take on this approach using MongoDB. For data ingestion, we have covered this piece already in this presentation. So we can use either Event Hubs with Kafka Connect, and if you're using IoT Hub, you can use Azure Functions. And if we look at this warm path, we can actually look at on how to query the data. So MongoDB supports a query language called MongoDB Query Language, and with that it has something called the aggregation framework. And these are designed to make it simple to query unstructured data, because after all, MongoDB, one of the reasons why it was so popular is because developers can just create their objects and insert their objects into a database. They don't have to worry about defining the columns and the constraints and things like that. They can just create the object and insert it, and as their object changes, that data changes as well inside the database. But if you query it through things like SQL, which is traditional SQL, that's designed very much for rows and columns and multiple tables and joins and things, and it just is very difficult to sort of map SQL with something that's unstructured. And so because of that, that was sort of born the Mongo query language and the aggregation framework. And the aggregation framework is much like a Unix pipeline command, where the output of one stage is the input of another. So the queries are essentially multiple stages. So say, for example, you issue an aggregation query. The first input of that stage will be the entire collection. And maybe the first stage itself is a match, where you're matching on date, for example. Maybe the date equals today. Now, the input of the second stage is the output of the first, and so that stage is going to be all the collections that have the date of today. And so maybe that second stage then will group the data by customer, and then it'll add a column called, average sales price, for example, or something. So it's very intuitive. Obviously, it's outside of the scope of this presentation, but it's the way that you can easily query MongoDB and query unstructured data. As far as applications go, we support many different languages like Java, C#, Node, Rust, C, Python, Swift, Ruby, Go, and really many others. And using an Azure function, for example, this is the way you would use it through one of the MongoDB drivers to get access to write and read from MongoDB data. You can also access MongoDB through APIs such as REST calls or even through GraphQL. We support that as well. And MongoDB has a lot of other capabilities like native visualization tool, making it easy to build dashboard and charts off of data. So remember, this is unstructured data. So traditional tools are a little bit more of like rows and columns. They sort of speak SQL. So having a native tool that interacts with arrays and subdocuments and understands that natively makes it really nice to be able to build these charts out. And we also have the BI connector. And so going along that same lines, if you think about traditional BI reporting tools like Tableau and MicroStrategy, Power BI, Excel, these were all born and raised on SQL-like data sources. And if you wanted to use MongoDB data with these other data and these tools, we really wanted to make it easy and possible with the BI connector. So the BI connector acts like a middleman between SQL-speaking tools like Power BI and MongoDB. And essentially, it stands up a MySQL Server front end, so it acts like a relational database. The tools connect to that endpoint. They issue their SQL statements. We take those statements and translate them into Mongo query language, execute them, and we give the results back to the client. And so in the end, these tools can natively use MongoDB data and intermixed with all the other data and the applications that they would for their particular use case. And there's also a Spark connector, and this allows MongoDB to work with Spark implementations such as Azure Databricks, so making it easy to take advantage of MongoDB within the Spark ecosystem. And so we've talked about all this in the context of warm data, but everything I've discussed really applies to cold data as well. And in MongoDB Atlas, you can archive data into inexpensive cloud storage by the way of MongoDB Atlas Online Archive. So as this IoT data that you have within hubs that gets moved out to Atlas for querying or long-term storage, that actually can be effectively pushed out to cloud-based storage where it's really, really inexpensive. It's really an effective way to manage the data growth problem by archiving and using this cost-effective storage tier. So, and this is the feature within Atlas that supports that auto archiving piece, and I'm actually going to run through that in a moment. But really, the key part here is not only can you archive out, so you can say I'm going to use this particular field I'm going to look at. Maybe it's the date that the IoT sensor came in. You could say after 30 days, I want to archive it out to slower storage. Well, you can actually create a federated query where you can query both the warm and the cold storage from the same connection string. And you could do a read-only query across the two. So you can actually essentially have both warm and cold in a single query. So now I'm going to kind of show you some of the things within Atlas that'll help you with the data that you have stored there. So I'm going to jump back over to my Atlas cluster, and you'll notice there is a charts button here. So this is MongoDB charts, and I have created some data sources. It takes about a minute or so to configure, so in the interest of time, I just added them. But these are the ones of the different MongoDB clusters that you can add. So I'm adding both our source and sink data sources here. And so I can come in here and I can create a dashboard. So this is maybe my Azure Event Hubs dashboard. And I'm going to hit create. And I can add some charts. So I'm going to choose a data source, and I'm going to use our sink. I would like to create a continuous line chart of our data. And you'll notice that the TX time, which is the time that this particular stock price happened, thinks it's a string. And I really want that to be a date. So I can come in here and change the data type to a date. On my x-axis, I'm going to drag time. I'm going to drag price on the y-axis, and my company name will be my series. And so what you'll notice here is that I didn't let my demo run very long. So obviously these lines are relatively flat because the price didn't change much in about 10 seconds. But you can see that I do have different values here. And within a couple clicks, I now have a visual representation of my time series data, or my IoT data that's stored in MongoDB. I can also embed this pretty easy. So if I go in here and I can embed this chart, so if I have a web page or something, I can enable authenticated access where I could just take this iframe or JavaScript and paste it into a web page. I can make it authenticated if it's proprietary data. I don't want it to be used or accessed by the public. I can enable authenticated access from here. So just really making it easy to go through and access that. So when it comes to Atlas, the other thing I wanted to mention here, in addition to all of the operations that you'd expect, you can do real-time analytics on the performance of your database. You could see what your hottest collections are, your sources and sinks, slowest operations, and so forth. So you get a real-time view, as well as you can hit metrics and see exactly from your replica set. So here's my primary over here and my two secondaries. You can see kind of what's going on. Op log size, database size, indexes, things like that are all available in one place. One of the interesting things we talked about before was online archive. So if I click on online archive, this is the capability that allows me to take the data and actually move it out to cloud-based storage. So if I hit next, for a namespace, I can just say event hub demo .sync. And the data field to archive on, I wanted that TX time field. I could specify, after how many days do I want to push it out to my archive? I can just say 1. This specifies the most commonly queried fields. This just helps you by creating the indexes you would need to make this the most performant. I'm going to hit next. And this sort of tells you, well, you can run this query right now to see which documents would actually be pushed over right now. And it tells you that make sure you have this index created because we require an index on the fields that you are pushing out. So once you do that, you can hit begin archiving, hit confirm, and then away it goes. And obviously, I only ran this demo for like 20 seconds, so there's nothing really to push out over to the online archive. But what's interesting is I did want to show you the connect button up here, that I can connect. I'm going to connect with my Mongo shell, and here's connect to the cluster and the online archive. So what I was saying is that if you wanted to issue a query across both the old archive data and both cold and warm data, you can do that here as well. It is a read-only query, but most of the time you're just looking for answers from that anyway. Great. So I'm going to go back over to present mode here. So I just wanted to provide some summary here. We did talk about Azure Event Hubs and Kafka Connect and MongoDB, which was the main area of the focus of the presentation. So this feature of Kafka Connect is in preview. I think compaction is the only thing that is missing currently in the preview release for this one, but I'm not obviously at Microsoft. I spent 17 years there a while back, but not currently there, so you'd have to talk to somebody on the product team to figure out when it'll be feature complete. I did mention the flexibility of the document model in IoT applications, how document model is really good, and JSON itself for being able to add different sensors, add different fields, and bring them back and so forth. And one thing I wanted to mention is that we see this a lot in tickets that are filed on MongoDB, is that Azure Cosmos DB API for MongoDB exists, and it's a way for you to use your MongoDB drivers against Cosmos DB. But one thing that's kind of important to note is that Cosmos DB is not MongoDB, so I think they're 3.6 compatible at this point. So you kind of get like a subset of the functionality. So we're about to release 4.4. So you don't have transactions or materialized views or any of this other kind of stuff. So if you're looking for a traditional MongoDB, you should use Atlas. And Atlas, there's no RUs. It's auto scale, it's auto archive. There's a ton of other features that I didn't talk about because it's not really an Atlas presentation. And you can use your commit to consume for MongoDB Atlas. So if you're on an EA that has that, that can also be used to satisfy that requirement as well. So with that, I can take any questions that anyone has.
Anybody have any Q&A for Robert?
Excellent. And so
Okay.
I just wanted to mention the GitHub link, I believe will be on there before, but if you're interested in the code itself, it is on here, and it's also on the slide deck, which is uploaded, and I believe you're going to be sending it out. So
Yes.
great. Excellent. And thank you,
Robert,
everyone. All right.